Okay, so this is example 1 that you see in your Nearpod. I just kind of traced the example so that we could take a look at it together. When we're doing volume, now we're looking at 3 different dimensions. We're not just looking at length and width, we also have to look at height. So if this was a box and I wanted to open the top of it and fill it up with something, the volume would be what I was filling it with. We measure volume in cubic units because now we are working with 3 different dimensions. So remember, when we cube something, it's to the 3rd power. So that's the 3rd dimension. So when I do this, I'm going to first always start with my formula. Volume equals length times width times height. Now again, it doesn't really matter which one you use as the length, the width, and the height. The commutative property kicks in here where it doesn't matter which way I multiply these 3 numbers, I should still get the same result. So I'm going to make myself a little love note over here though, like I did with surface area, to label my length and my width and my height. That way I make sure that I've used all 3 numbers that I have in my example. So I'm going to call the length 8 because that's the longest piece. I'm going to call my width 2, and I'm going to call my height 5. So I'm going to go ahead and I'm going to substitute those 3 numbers into my formula. So my length is 8, my width is 2, my height is 5. So now I just have a fairly simple multiplication computation to do. So I'm going to say volume equals, because I still don't know what my volume is, and I'm going to take it a piece at a time. So 8 times 2 is 16, and then I bring down my multiplied by 5. 16 times 5 is 80. Now, I always need to look at what the units are that they've given me, and I need to make sure that I cube this instead of squaring it. That's very important because that tells any other mathematician who picks up my example that I cubed it because it had 3 different dimensions to it. So that is example number 1.